Welcome to From Learning to Thinking in GraphQL. Maybe some of you might be familiar with this slide. So we are actually now not in the end game, but we are in the real end game, right? So maybe a little bit more about me. My name is Glenn Reyes. I am Glenn Reyes on Twitter without the E's, so please follow me if you want. And I'm also a freelance engineer, mostly working with stuff like React and GraphQL. And what I'm currently doing is I'm currently contracting for some San Francisco-based venture capital called Kleiner Perkins, working on GraphQL migration. And besides that, I enjoy spending my time with my family, and I love to play the guitar, and I love to discover places. So this talk, I'm going to focus mostly on GraphQL. Maybe short hands up. Who is anybody here familiar with GraphQL? Quite a few, not too many though, like 10 people maybe. Who is using it in production? Much more than that. Somebody here who is hearing for the first time in GraphQL? Okay, a lot of lazy people. Okay, let's start with the question: what is actually GraphQL? Quoted this from the GraphQL documentation. GraphQL is a query language for APIs and the runtime for fulfilling those queries with your existing data. So what does it mean? GraphQL is basically just a very thin layer where you just ask for what you need and then get exactly that for what you have asked for, right? So specifically, if you describe a request in a JSON-like format, and in GraphQL it's called GraphQL query. And what you see here is you query for your profile, me, for example, and you add all the feeds that you need, that you want to query for, right? So in this case, you want your name and the age and your bio and maybe your Twitter handle. And by that, you should be able to get the exact same shape in the output. So you get this, but with the values and the results, right? And this is basically the core concept of what GraphQL does and what makes it so really powerful. Because when we look back at GET requests in a REST architecture, what you do here is you ask for data and send multiple requests. You ask for data in me, and then you ask for a user's friends, and then after that you have to normalize all the data in the shape you need in the front end, right? And so in the GraphQL query, this basically allows you to move all the work of shaping data and doing all this data normalization in the front end to the GraphQL application. And also, one of the biggest benefits by doing that is that you are able to avoid overfetching and very easily. And that's just a very high-level concept of what GraphQL does in general, right? So there are 4 main parts that forms the GraphQL core concepts, which one is the queries that we have just seen before for describing the data that you want to fetch. And the second one is mutation, which is very similar to queries, but the difference is you use mutations just for adding new or changing the data or deleting the data. And GraphQL comes with its own language called the GraphQL schema language or schema definition language. And what it basically does is it allows you to talk about schemas in a language agnostic way. So this means it doesn't really matter in what language you write your GraphQL server, because your front end can communicate with any GraphQL server. It doesn't really matter in what language is written, right? Now, when it comes to get started with the GraphQL, like with setting up the GraphQL server, one of a big hurdle of getting started with GraphQL is to set up the tooling and set up the server environment, in my experience. And I found a really good starting point with creating a server was getting familiar with Apollo server. And Apollo server is just a really simple GraphQL server in Node and JavaScript, written in TypeScript. And because it has all the best practices and patterns that has been gathered over the past years on writing GraphQL servers. So you get all the nice utilities out of the box, like GraphQL Playground, or which was the GraphQL IDE, like the graphical before. And you also got subscription support out of the box, and many more. You can literally paste all this in a file, like the code that you see here, and run it in Node, and you have basically just a really solid GraphQL server up and running. Yeah, that's what you get by this code. But the thing is, you still may want things like while you're developing it, like live reloading, and you may want to work with the latest ECMAScript features, and setting up all these costs time, right? So what else do we have here? And that's where Graphpack comes in. It's actually a project which I have just published like 2 months ago, and it's a zero config GraphQL server which allows you to run a server by a single command. So think like create React app or Next.js, but for GraphQL servers, right? And the cool thing about Graphpack is it's built on top of Apollo server. So this means everything you get at Apollo server is there. And I've built it with TypeScript support out of the box. It has live reloading thanks to Webpack and NodeMon from Reyes, and also like you can use the ES features. You can just customize your Babel configuration with it, and also friendly errors. And basically, what it does, it hides all the boilerplate that you need for a server setup. And what does it mean, like hiding all the boilerplates? The concept of Graphpack is you basically need 2 parts or 2 files in your app, which is your resolvers and your schema. And by that, I found it's a really great way to scale an app really nicely, and it allows you to focus on the 2 most important things, right? So writing your GraphQL types and its resolvers. And running Graphpack is as simple as I've mentioned before with create React app or view CLI, because it comes with just only 2 commands. And one is just to start the server with all the stuff you need for development. And you get here live reloading and source maps, everything out of the box by running that. And the latter one is just for creating a production build, which is then an optimized file that you can run in Node very easily. So the idea behind this is that you put these commands into your package.json run scripts and just run, for example, start. And the dev server and this would look like this. It will show you a nice, friendly output, and everything. And every time you make a change in your code, it reloads your server automatically. If you produce errors, it will also display it for you in a really nice way, like here. So if anybody here is working with Next.js, you probably are familiar with this because it's the same Webpack plugin it uses behind the curtains. And that's Webpack. And consider using it to move faster with GraphQL development. By GraphQL development, I mean GraphQL server development. And in general, I found it's super useful to just use tools that takes some jobs for you and to focus on writing actual GraphQL. So if you want to build a GraphQL server, try not to waste too much time on setting up the tooling, since it can get frustrating especially when you just get started. So if you're interested about Graphpack, it's available under my GitHub account, glenreyes/Graphpack. So check it out, let me know what you think. Maybe share some ideas and open PRs, give it a star. I'd love to hear about more. and hope to make it even better together. Now, I want to share some interesting parts when it comes to start writing some actual GraphQL code. I think we can basically break it down in these 3 different steps. So first, we need to create a mental model, which I'll explain later a little bit more. And second, we define our types. So remember, types are the components that build the schema. And third, we need to implement custom resolvers to feed our GraphQL app with actual or real data. So the first step, create your mental model. What does it mean? So let's imagine maybe a Twitter-like profile page where you just have this, and you want to describe the data. And this is a very interesting part, because this is the part where you start engineering and like identifying the model, like what are the parts on how to break it down. So very, very rough. Thinking about data, it's a really simple example. We can say that the data we want to represent here is maybe some information about the user, and in the bottom part is maybe the information about the posts. So these are basically the posts. Then you might think of its relations. So like in this case, it's a very simple example. It's clear that the bottom part is are the posts of the user, because we are here on the profile page of the user, right? And as we think more about it, we see that, or we might have like a profile photo and a cover photo. So it could probably make sense to extract extract this into extract the photo into its own type. And in GraphQL, it's, in my opinion, a good practice to break down things as much as needed as possible, as much you can do, because I believe that this leads to less breaking changes, and it scales a lot better. So the second step is you need to define then the types. So as I've mentioned before, GraphQL comes with its own language. So in this case, you basically want to add the user type with its fields to the schema. So you have this source/schema.graphql. That's when you use Graphpack, you would define this. You would define basically this code in this file, and you'll see just cover photo is a type of string, profile photo, display name. You have ID, username, and all this, and string is a default type which comes from GraphQL. And note all the exclamation marks that you see here. These are basically indicators for non-nullable types. So this means these are required types. It has to be a string, right? So to me, I've found it's a good practice. Prefer non-nullable types over nullable types. So nullable types are without the exclamation marks. So make it non-nullable by default. And when you realize it should be nullable, then consider it just a switch. And you also see posts, which represents a list of strings that are all required. So this means this has to be an empty string or a list of strings. So also, if we think more about this, it's most likely that we need more information about a post, right? So we might also have information like the creation date of a post, or an update the updated date, etc. And the next step would be to convert this into another object type, so which is our post, right? So the post includes the fields like ID, created ad, message, and so on, whatever you want, whatever you need. And in the user type, posts are now a list of posts instead of strings. So now we have two types, the user and the posts. Now, to provide more information about photo, we can do the exact same thing with a photo. So we create an object type for photo. And now the cover photo and profile photo, uses the photo type instead of the string, right? So in the photo type, you can now describe the file name and any more information you need about the photo. So the main takeaway here is, as I've mentioned before in GraphQL, I think it scales a lot better to describe types as unique as possible. So this leads to less version updates, which reduces deprecation processes and so on. Now, to feed our GraphQL with some real data, we have now to implement its resolvers or its custom resolvers. So resolvers are nothing more than a list of all the types we have described and where you can just load some actual data. So that's the point where you want to put your model or your Axios library or your fetch, where you could just fetch the data from a database or your microservices, right? So in this case, we have query, and the query has the user, and the get user is the model, which probably, where you just get the user, and it returns a promise of the user, right? So the same thing with the users, and users posts resolves basically the user's posts by the user ID given by an argument. Now, how does a query look like? Before we go deeper into this, let's see how it was done with REST. So again, let's imagine this profile page, and we're moving now to the client, right? So what you in REST, what you need to do in the front end is, in this case, like you fetch the user, and then you get the information about the user. You get like IDs about the profile, photo ID about the cover photo, and then after you get that, you make another request to the photo endpoint, and grab the photo, and then you get information about the photos, and then you might have tagged users in the photo. And then again, you end up having like this huge like waterfall request, and then after you have fetched everything, you have then deal with normalizing and bringing it into the shape how you would need it in the front end, right? Now, GraphQL will move this all away from your client, and all you need to do is to describe everything in a query in a shape how you want to do the data in the front end, right? Here is just a really quick example of how you use the query in React. So I'm using here React Apollo. You basically import the query render prop component, and you pass a prop called query with the GQL tag. And then in the GQL tag template string, you put in your query, and the query also allows you to pass some variables. What I'm doing here with the username, and the render prop gives you two main props, which is the data and the loading flag. The loading flag, you can say if loading, then return me a loading string, and otherwise, if the data is not there after it still has loaded, for example, if there's an error occurred or something, then just return nothing, and otherwise return just the data or in my profile component. So this is all nice and all cool, but at some point you bump into the case where everything gets really complex and gets really big and slow and all that, and you have to do something about it. So there's sometimes a fourth step, which I found is good to do, which is defer expensive parts. So what does that mean? So given our profile page, once again, we have seen this could be easily split into two parts, right? So we have the profile part and the user and the posts part. And one option to do that would be to create two different queries for the front end. So one that queries only the profile information about the user, and do another query that only queries the posts of the current user. And you can do that you can load these parts in the page very independently, like here in the upper part and the bottom part, and it's basically like you're code splitting, but on a query like GraphQL level. Another experimental option is the so-called add defer directive by Apollo. So you see the add defer here at the posts field, which I think is a super smart way to do. The only thing is, the last time I've tried it, which was like I think 3 or 4 months ago, or something, it didn't work quite well at the time. So I'd recommend, once this moves away from the alpha version, it's worth to give it another shot, for sure. Now, how about mutations though? Super similar to the query that we've seen before. You also update the resolver, and what you can do here is you can just pass arguments. And common practice of mutation is also like the naming. So it's important that you add a verb and then add the object that you want to do. So for example, change profile photo or update bio or submit posts. Some teams are doing user create. It's also fine to do that as long as you stay consistent within your team. And the second thing is specificity. And this means your mutations should be as specific as possible. So you might prefer change profile photo over update user, for example, where you can just do a lot of things, right? So you might have like change profile photo, change your display name and all that, and just be specific with all your mutations. And there is another special thing here, which is the input object, which is a single argument in your mutation. And it's a really nice practice to have this in a unique and required shape to use. So on each mutation you do, it's really nice. It's really recommended to have a unique input type for each mutation you do, right? And the same goes with the unique payload type, which is the return type of the mutation, because every time you run a mutation, you get results from I don't know, from one type that you have. So like here, it's the change profile photo payload, and what you can do then is in the change profile photo payload is you can take photo as a field, and you can add meta information like the client mutation ID to this payload, right? So whenever you nest, it's completely fine to do that in GraphQL, because it's just a lot better to work with it like that. So to wrap up, naming, use verb and object like update bio, submit post. Be specific, make mutations as specific as possible. Input objects, make every single mutation, make it unique, make it required, and use also a unique payload type, and nest whatever you need wherever you can. So a fairly frequently asked question is also how to handle authentication in GraphQL, and the answer to that is GraphQL doesn't actually handle any authentication, but the context is the perfect use case for that. So context is a part of the server where you have then access to the request object, for example, like think of Express server. So what we do here is if the user object exists, it return true, otherwise false. So we return then is logged in, and the user object to return the login state, right? So on each resolver will then have access to the context and can handle logged in state like this. So if the user is not logged in, we can throw here, for example, some errors, and if he is logged in, just fetch the user. Or I don't know. So because you have access to the context on each resolver, it's also super neat to have this feature for access control. So this means you can have access you can control the access on each and every field that you have if you want to, right? So another thing is batching requests. Why would I need it, or what is it? So for example, if you had a large query where you fetch multiple data at once, you have to fetch each user one by one and on each request. So there are APIs where sometimes you'll be able to filter them by a URL parameter. But imagine resolving this request in the front end dynamically. It can be really messy and complex to do that. And in my opinion, data loader is the perfect use case for that because it allows you to batch and memorize or cache these types of requests into a single one. And it works something like this. In your context, you define then your the data loader, and here you call the fetch, and the keys argument here is basically a list of all the IDs you get in when you, for example, when you fire a query or something, and then in your resolver you use the load function to basically load the data and memorize it automatically. So you can use the load function on multiple places in your GraphQL server, and then on complex queries, the batching and caching is like magically happening and done for you. So all this will avoid basically overfetching in your GraphQL server. So I totally recommend data loader when it comes to make your app faster and to save a bit more loading time. Now, what about storing data? Since GraphQL is just a very thin layer, it's basically up to developer how or where we want to store the data. GraphQL is not really tied on any database. All you need to do is just to create your models and query them in your resolvers. And in my experience, I had really good times with Knex.js, which is a query builder in JavaScript. So it supports MySQL, Postgres, SQLite. And here is an example of using it with MySQL. And it has this kind of like a jQuery-like API where you can just chain all the different operations like .select and .from, and yeah, it does all the nice parts. A lot better experience. I got the chance to try Prisma, which is a database tool designed with GraphQL in mind. And since it's written in TypeScript, you get all the nice utilities out of the box, like auto-suggest in your editor and all this stuff. Yeah, so also it's worth to talk a little bit about the folder structure. I've encountered three different types of folder structures, which the first one is like simple, like all in one file. So you have everything, every resolver is in your resolvers and your types all in your schema GraphQL. And if it gets more complex, you can consider doing by types. So this means you have all your models in your in one directory, all your resolvers in one directory, and maybe your types also in different files in a directory. The third one is by feature, which means you start now. For example, if you have a GraphQL server for conferences, you could have like a folder for speaker, which is basically the type you use, and you gather like the resolver and the types in this folder, and everything that has to do with, for example, with a query, you get everything in this folder and so on. And this is also a nice way to organize your GraphQL application. But my advice is always start simple, switch gradually once it gets messy, and consider switching by types. Then if it doesn't help the structure, try structure your project by features. And when you start, actually don't worry much about it. I've spent so much time on bike shedding with folder structures. It's a lot better to spend time on focus on GraphQL and do the business things and dev things first. So I know my time is up, but I'm here at the last slide. So to wrap up my talk, here are the things that we have learned now. We know the core concepts about GraphQL now. Use Graphpack for building GraphQL servers really quickly. And I recommend two approach to write, create the mental model first, then think about the types, write its resolvers, and maybe defer expensive parts. And there's mutations. Think about the naming. Be specific with your mutations. Use unique inputs and payload types. We've heard about authentication and access control. Data storage. GraphQL is not tied to any database. And if you want to batch, if you want to be more performant, use data loader. Also, avoid byte shedding on when it comes to folder structures. So that's all I had. Thank you very much.